Hello, everybody. Today we're going to look at how we can use contingency tables to calculate some probabilities. Now, contingency tables help us organize and analyze how two variables relate to each other, and that's what this table is right here. This is called a contingency table. Now, it displays the frequency counts of the data for each of the variables. And so we have one variable that goes in the rows, and then we have one variable that goes in the columns. So a quick refresher, when we're finding probabilities, the basic idea is we want to look at the number of desired outcomes and divide by the total possible outcomes. So that's what we're going to do here. Now, so that we can practice our probability notation, I'm going to say let C represent that the person likes the Celtics, and I'm going to let B represent the event that a person likes the Bruins. So in this chart, we have a survey that was conducted among 300 residents of Boston to determine their preference for the two teams, the Celtics and the Bruins. And then that's displayed here in the chart. So in part A, we're looking for the probability that if I randomly select someone from this group of 300 people, what's the probability that the person is going to like the Celtics? So our probability notation for that would be P, and then in parentheses, we would have C, the probability that someone's going to like the Celtics. So what we're going to do is we're going to look at how many people like the Celtics. That would be this column right here. It's a total of 170. So 170 is our number of desired possible outcomes. So that's 170 out of the total of everyone, which is 300. Now, typically with probability, we like to round to 4 decimal places unless we tell you otherwise. And so when I take 170 divided by 300 and I round it to 4 places, we're going to get 0.5667. All right. Now, between each part, I'm going to erase my drawings on the table. That way, it doesn't get cluttered and you can see it better. Okay, part B says, what's the probability that if we randomly pick someone, they like the Bruins and the Celtics? So our notation for this would be the probability of the Bruins and the Celtics, or another way to say that using our mathematical symbols is using the upside down U, the Bruins and the Celtics. So we want to look on the table and figure out how many people in this table like the Bruins and the Celtics, and then take that out of the total possible, which is 300. Now, when I look at the table, we have 120 people that like the Celtics and that like the Bruins. That's where they overlap. So that's going to be 120 out of 300. And when we put that in decimal form, that's going to be 0.4. Part C is likes the Bruins or the Celtics. Now our probability notation for that would look like this. Using our mathematical symbols, the or statement symbol it looks very similar to a U. Now, there are 2 ways that we can do this. I'm going to split this into method 1 and method 2, and then you can decide which way you like to do it. All right, method 1 is we just look at each individual subgroup in the table and decide if it satisfies the statement Bruins or Celtics. So all we have to do is satisfy one of those statements that they like the Bruins or they like the Celtics for it to be in the set Bruins or the Celtics. So if I look at this first subgroup, that 120 definitely falls in the category of liking one or the other. In this case, this is the group that likes both, so it's definitely satisfied. So I'm going to add that to my number of desired outcomes. When I look at this next group here, this group of 60 is the group that does not like the Celtics, but likes the Bruins. This definitely falls in our category of likes the Bruins or likes the Celtics, so I'm going to add that to my desired count. When I look at this group of 50 right here, that group of 50 likes the Celtics but does not like the Bruins. So still, it's satisfying one or the other, so I'm going to add in that 50. This last group of 70 does not like the Celtics and does not like the Bruins. So this does not satisfy the condition of liking the Bruins or the Celtics. So this is our final count. So I'm going to take 120 plus 60 plus 50. That's everybody that likes one or the other or both. And then I have to divide that by our total, which is 300. When I do that, I get approximately 0.7667. Now, method 2 is where we consider the overlap or the double counting. This is my preferred way to do it, but that's not to say that you shouldn't use method 1 if you like method 1. Let me erase so we can look at this method separately. All right, so if I look at all the people that like the Bruins, that would be this group right here, 180 people. So I'm going to add that to my list of desired possible outcomes. Then let's look, I'll use a different color. Let's use purple. If I look at all the people that like the Celtics, that's 170. However, notice that in both of my counts of 180 and 170, I counted this 120 in both groups, right? I counted that 120 when I went down and added up all the people that like the Celtics. And then I counted that 120 and everybody that liked the Bruins. So I double counted. So I'm going to subtract that extra 120 off so that we don't double count. And then I'm going to divide by my total. So I'm going to take 180 plus 170, subtract 120, and then take that answer and divide by 300, and I'm going to get the same answer. So you choose which method you like. Either one is fine, and you want to use one of these two methods when you're talking about an or statement. All right, let's look at part D. Part D says, what's the probability that the person does not like the Celtics? So if we come up here and look at all the people that don't like the Celtics, in this group, there's 130 out of 300. So we're going to write the probability that the person does not like the Celtics is C complement. So one way we could calculate that is like what we just did. We looked at all the people that didn't like the Celtics. That's 130 out of 300. So that's 130 out of 300. And when we do that, we get 0.4333 when we round it to 4 places. Now, the other way that we could do that is take 1 minus the people that do like the Celtics. So all the people that like the Celtics is 170. So if I take 1 minus 170 over 300, I'm still going to get the same answer of 0.4333. And don't forget, there's different notation for the complement, right? I could have written it like this with a bar, or I could have written it like this with a little prime symbol. Any of those symbols represent the complement, which is not liking the Celtics. It's not C. All right, part E says, what's the probability that someone doesn't like either team? So they don't like the Bruins and they don't like the Celtics. So we would write that as the person does not like the Celtics and they don't like the Bruins. Or you can write it like this. Okay, this is not C and not B. So the people that don't like either, if I look at the chart, the people that don't like the Celtics and they don't like the Bruins, that is this group of 70 here out of 300. Now, when I divide and I round to 4 places, that's going to give me 0.2333. The last 3 examples, F, G, and H, these are conditional probabilities. Let me make a note. And I know that they're conditional because we're given assumptions. So we're going to make an assumption to narrow down. Instead of taking it out of the full group of the 300 people that were surveyed, we're making an assumption so we can narrow it down to a smaller group. Okay, so looking here, it says, given that the person likes the Celtics, what's the probability that they also like the Bruins? So here's how we're going to write our notation. Remember, whatever goes to the right of our line, our vertical line, is our assumption. So our assumption is that the person that we're picking likes the Celtics. So we're going to draw our line and then see. What we're trying to find the probability of is if they like the Bruins. So the B goes in front. So we're going to say the probability of B given C. Now, because we're assuming that the person likes the Celtics, we're not looking at the full 300 anymore. We're only looking at the people that like the Celtics. And we're trying to find the probability that someone likes the Bruins out of the group of the people that like the Celtics. So in this group, and this group only, the people that like the Bruins, that's 120. So we're going to find the probability by taking 120 out of 170. And again, that is because we narrowed the group down to our assumption, which was the people that like the Celtics. So we have 120 out of 170. And when we divide that, we get 0.7059 when we round to 4 places. Part G. Given that the person likes the Bruins, so this is going to be our assumption, what's the probability that they do not like the Celtics? So our notation is going to look like this. We're making the assumption that the person likes the Bruins. So the B is going to be on the right-hand side of the line. That's going to be our assumption. And we're looking for people that do not like the Celtics. So this is going to be the complement of the Celtics. Because our assumption is that they like the Bruins, we're only looking at the people that like the Bruins. So we're looking at just this group right here. So out of the group that like the Bruins, how many don't like the Celtics? So that would be 60 out of 180. So when I take 60 and I divide by 180, I get 0.333 repeating, and we just round it to 4 places as 0.3333. Now, for the last example, we are looking at another assumption. We are saying that our assumption is that the person does not like the Bruins, and we're trying to find the probability that the person likes the Celtics. So we are going to be looking at the groups that do not like the Bruins. So out of the people that do not like the Bruins, that's this group right here, we're finding the probability that the person likes the Celtics. So the people that like the Celtics in the group that doesn't like the Bruins, that's 50 out of 120. So we would say, what's the probability of a person liking the Celtics given that they don't like the Bruins? And we said that that was 50 out of 120. And when we round that to 4 places, we get 0.4167. Let's look at example 2. Now, there are times where you're going to want to make your own table. So I left this table blank so we can fill it in and learn how to make it ourselves. And so for this example, we're talking about Boston commuters and weather. Boston transportation officials are interested in how the weather affects commuting habits. A random sample of 250 Bostonians was taken, and each person was asked whether they commute by car or public transit, and then whether the weather that day was clear or rainy. So our 2 variables is how they're commuting and the weather. Now it tells us in this question that there's a total of 250 people in this group. So that's going to go down here in our total. Now it says officials noted that 90 people used public transit on a clear day. So there's 90 people that used public transit and it was a clear day. So that would be this group of 90 right here. Then it goes on to say that 50 people commuted by car on a rainy day. So that would be this group right here where it's rainy and travel by car. We're also told that additionally, it was found that there was a total of 110 individuals in the sample used a car as their method of transportation. So we know a total of everybody that used the car was 110. And then 100 experienced rainy weather during their commute. So there's a total of 100 that experienced rainy weather. Now, even though we're not given the rest of the information, we could easily fill it out because we have enough information to do that. I know if there's 100 people that experienced rainy weather, thinking about the complement, I know there's a total of 250 and 100 experienced rainy weather. So I know that 150 experienced clear weather. Because 110 people used their cars that day, I know that 140 have to use the public transit because it has to add to 250 for the total. And then using that same logic, the people that drove the car on a clear day would have to be 60 because 60 and 90 have to give me 150, and then also 60 and 50 need to give me 110. And then lastly, we can fill this in, 50 and 50 have to give me 100. So we have our table of values. Now let's use it to answer the probabilities. All right, so what's the probability that a randomly selected commuter used public transit? So let's let T be the people that used the T. And let's use C if they used a car. Let's use NR for no rain. And let's use R for rain. So for the people that used public transit, our notation is going to look like this. So we need to find the total number of people that used public transit, which is this 140, right? If I look across, that's 140 out of 250. And when I divide that, I get 0.56. So now the people, what's the probability that someone experienced clear weather? So the number of people that experienced clear weather was 150. So we listed that as NR for no rain. So that's going to be 150 out of 250. That just gives us 0.6. For part C, we're going to look at what's the probability that someone used a car or had rainy weather. Now, I'm going to use the method in which we subtract off the double counts, but you can use either method. Just make sure whatever method you use, it matches my answer. So the notation for using a car or having rainy weather would look like this. The other way you could write it is just using the word or. The number of people that used a car was 110. The number of people that experienced rainy weather was 100. But I double counted one of the groups. The people that I double counted was the group of 50. I counted that group of 50 here. Once in the rainy group and then once in the car group. So I need to subtract off 50 and then divide by the total that we have, which is 250. Now, when I take 110 plus 100 and I subtract 50, and then I divide by 250, that's going to give me 0.64. Part D says, what's the probability that someone did not experience rainy weather? So there's two ways we can do this. We can use the people that had clear weather, which was no rain. And if we do it that way, that would be 150 out of 250. The other way we could do it is use the complement. If I find the number of people that experienced rainy weather and did the opposite, it would give me the same result. So I'm going to take 1 minus the number of people that experienced rainy weather, which is 100, out of 250. Either way, you should still get the same answer, which is 0.6 when you do that arithmetic. Now, we could do the same thing for part E. We can find the number of people that used transit, which is, we call that T. And the number of people that used the transit system was a total of 140 out of 250. Or the other way we could do it is use the complement. The people that did not use the car would be the complement of the cars. So I would do 1 minus the number of people, or the probability that someone used the car. The probability that someone used a car is 110 out of 250. No matter which way we do it, we should get 0.56. Part F says, what is the probability that a commuter used public transportation and had clear weather? So our notation would look like this. Here's our and symbol. It's an upside down U. And clear weather, we labeled that as no rain. So the other way we could do it is just to use the word and. So if we look up here and we find the group of people that used the transit and had clear weather, that would be 90 out of 250. And when we divide that, we get 0.36. Our last two examples we're going to look at are conditional. We're making an assumption. Given that a commuter experienced rainy weather, what's the probability that they used public transit? So we're going to assume that the person that we're picking experienced rainy weather. So we're only looking at the group of people that experienced rainy weather. And we're looking at the number of people out of that group, the rainy people group, how many people used the transit. So if we come back up and look at here, the number of people that experienced rainy weather, that was out of 100. And out of that group, there were 50 that used the public transit. So for this answer, we're going to have 50 out of 100, which is 0.5. Okay, last example, given that a person used a car, what is the probability it was clear? So we're looking for the probability that there was no rain under the assumption that the person used the car. So we're only looking at the group of people that used the car, and then out of just that group, we're looking at who experienced clear weather. So out of the people that used a car, the number of people that experienced clear weather was 60. So our answer for this is going to be 60 out of 110. And when we divide, we're going to get 0.5455.